Amines. An amine is a hydrocarbon that contains what we call an amino group. Whoops. Amino group. And an amino group is just something that contains nitrogen, and the group that we typically see here is a NH2 group. Now there's three kinds of amines. The first one is called a primary amine. The symbol 1 degree means amine. Oh, sorry, the 1 degree means primary. And a primary amine is just an NH2 group that is connected to a R or a carbon group somewhere. So for example, we could have a structure that looks like this with a NH2 group up top, and the NH2 group is connected to some kind of carbon thing on the other side. A secondary amine, which the symbol is 2 degrees, a secondary amine is a NH2 group that's connected to two R groups, okay? And the two R groups could be the same or they could be different. An example might be that you have an N, okay, which is connected to two carbons, okay, one on this side, one on that side. So it's actually kind of wedged in between two carbon chains. This is called a secondary amine. Notice here that once we put on the extra carbon to the N, we had to ditch one of the hydrogens. Okay, remember that all atoms have a maximum capacity for how many bonds it can make, and for nitrogen, the maximum is 3 bonds and then 2 dots. From our formal charges lesson, remember that nitrogen is the most stable when its formal charge is 0. And if you have a nitrogen with 3 bonds and 2 electrons, then the formal charge is 5 valence, which is the original, minus the 1, 2, 3, 4, 5, which gives you a formal charge of 0. Okay, so that's why these nitrogens look like this. And the last type is called a tertiary, okay, tertiary amine, which stands for nitrogen, which is bonded to 3 carbon groups. And again, these R groups here can be of the same size or each different, doesn't really matter. And so this N here has lost both of its H's, and instead it's bonded to 3 carbons and with 1 lone pair remaining. So an example of that might be that you have this N here, and then instead of an H down bottom, you have another alkyl chain. Amines act as an organic base, which means it has base-like properties. It can also form H bonds when it is set up like a primary or secondary, because an H atom is connected to the N, which is very electronegative in comparison. Amines also smell fishy, like the stuff that smells terrible in your urine. Those things have an amine group. Amines are especially important if you go on to take biology 12 or any biochemical studies, because amines are a large part of protein chains. This is why if you eat a lot of protein, your urine smells worse and worse, because the breakdown of protein gets you amine molecules. So very important in biological systems, which is why we have to learn what they look like and learn how to recognize them when we see them. The name in amines ends in amines, which is nice, but actually the ending amine doesn't apply to all amines. It actually depends on which type of amine you're looking at, the primary, secondary, or tertiary. And some amines are circular, and those have their own endings too. So it gets kind of complicated. In Chem 11 though, we're only going to focus on the simple primary amines. And when we're naming primary amines, the name of the whole molecule, the ending is actually just whatever alkane or alkene it is you're looking at, because in primary amines, the amine group is treated just like a regular branch. So let's do some examples. Let's start with a condensed structure example. CH3, CH2, 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 CH, CH3. Here is the NH2 group. In primary amines, and again, you know this is primary because that N atom is only connected to 1 carbon. In primary amines, we treat that just like a regular old branch. So we number off the main chain in a way such that the branches get the lowest set of numbers. we go. That NH2 group is on carbon 2. We write 2 dash, and the name of NH2 when it's a branch is called amino. So this is 2-amino hexane because it's a alkane chain. Let's do another one. Here we have another alkane chain. This time let's add some branching other than the NH2. Here we go. First step is to figure out how to number the main chain. Again, our priority is to keep the number set as low as possible. So the easiest way to do that would be just to go from the left. 6, 7, and 8. You see we have 2 branches. We have an ethyl group and an amino group. And again, we go to our alphabetical order rule. We write the amino first because it starts with the letter A. That's 4-amino, 3-ethyl, and then we finish it off with octane. And our last example, let's do a long one with a couple of branches here. There you go. Okay, keep number set as low as possible. It seems like we should, well, let's see. We have 2 options here. We can either go from the left, in which case it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or we can go from the right and get 1, 2, 3, 4, 6, 7, 8, 9, 10. Which numbering system are we going to choose? If we choose the red one, we have branches at 4, 5, 6, and 8. 4, 5, 6, 8. If we choose the green one, we get 3, 5, 6, 7. So it looks like the green method wins because that is the lower number set. Alphabetical order, we start with the amino group. This is 3-amino. Then we have 3 methyl groups, all at the same size. So we just list off the numbers here. This is 5, 6, 7. There are 3 methyls, so we use the prefix trimethyl. There's 10 carbons, so this is decane. 3-amino, 5, 6, 7 trimethyl decane. And there we go. Again, our focus here is only on the primary amines. They're the simpler ones of all the amines that are out there. When we're dealing with primary amines, we just treat the amine group as a regular old branch, and we call it amino, like fluoro and bromo and chloro, and now we have amino. Okay, go out.